Hey everybody, welcome to the CoinGeek RoundTable. I'm your host, Becky Ladid, and this is actually the first roundtable of the year. And I actually think that we are going to be covering the most exciting topic of the year at this episode. We are talking about the future internet, and we're going to be diving into how blockchain and IPv6 play into this whole digital revolution that we are in the middle of. So I have some amazing guests that I'm going to introduce to you in just a moment. And we promise not to get too technical here. We are going to focus quite a bit on business use cases. So there'll be something for everybody. And please bring your questions because we will be taking them live during this roundtable. And I have, like I said, some amazing guests who are full of information for you. So before we get started, we're just going to take a break for a quick ad and we'll see you in a few minutes. Hey everybody, welcome back. More like a few seconds than a few minutes. So yes, I'm here with my guests. But before we get started, I just want to remind everyone to please subscribe to the CoinGeek channel and to hit that notifications bell so you do not miss a future episode of the CoinGeek Roundtable. So hello boys, welcome our guests, here we are. And what I'm going to do is have everyone introduce themselves in a moment here. But just so everyone knows who's watching, the way that this is going to work today is that we are going to do our intros. Then we are going to get into a bit of IPv6 and the business use cases that IPv6 is going to bring to the world, the innovation behind all of that. We're going to take a break and answer some questions. And then we're going to get into how blockchain technology plays into all of this. So lots to talk about today. Please throw your questions in there so we can answer them live. That's what makes the discussion very exciting. But let's start off, guys. I'm going to have each of you introduce yourselves, give a little bit of background into your area of expertise and the companies that you're representing. I know we have some nice slides from a few of you. So I'm going to start with you, Latif, because I know that you have some nice visuals to help our audience understand a bit more about IPv6. So please go ahead.
Can I share my screen?
Yes, go for it.
As they say, power corrupts, but PowerPoint corrupts absolutely. Let me see to get this one. Right.
Perfect.
So yeah, Becky, thank you. You're one of the best, my favorite reporter on one. Quite a rare thing. I'm gonna, within 2.5 minutes, browse through a few things, not to go into detail. We can have the questions. So basically, the first good thing we have is that IPv6 is booming around the world. So we reached 50% worldwide V6 penetration. The UK is among the top 3 in Europe. First one is 70%, and then Germany and the UK following up. And on a worldwide basis, I think Asia has about 2/3 of the IPv6 deployment. It's quite obvious because these are big countries with billions of people, but they are catching up quite a bit. All kinds of new technologies. So they have 5G and even work on quantum computing and the likes. So I expect them to be very innovative. And then here, the restoration of the end-to-end model, in this case, that things can talk to each other. So at the beginning was basically the only thing that you could reach because it has its own IPv4 address is the web. So the web was the first good application. And then we worked on 3G, 4G, Basically, Apple, by introducing the iPhone, killed 3G because they needed more bandwidth and created the wireless revolution that we are going through. And then IoT is the next place, but the majority, only the high-end side of IoT is using the Internet protocol, primarily today IPv4, and down the road we'll have more IPv6 IoT large networks. But the low end of IoT is rather using LoRaWAN as such, similar to Bluetooth. And obviously the next thing that we are working on, which is very interesting, is the next revolution, which is blockchain. And I have two of my colleagues with us. That's Mathieu. He's going to talk about the Bitcoin certified addresses. And my friend Lawrence is going to go after all kinds of security issues as well as PKI, because he was one of the active partners back in these days, at the very side. So with this, basically, we are going to have a lot of use cases, be it supply chain, primarily the food supply chain, because we know from some of the stats in the US from IBM that the US is losing about 30% of its food only in the supply chain. So you can imagine also by 2040, as they say, the US will have to import half of its food from around the world, which will most probably create hunger in the other places. So we have to make sure that the food supply is going to be working. But this applies to all kinds of assembly lines and so on and so forth. So I think it's quite interesting. And quickly here, currently nobody has its own IP address. So you're just using a fake IP address, which is like the extension number on the phone, like in the 60s, 70s. So that's why you're not doing end-to-end, and you cannot really run properly blockchain as such. So everyone is in the luggage class today. And those that are having IPv6 today, without knowing it, and they shouldn't know it, they are already in business class. And our task is to move to IPv6 only. In this case, sunset IPv4, so that we can do proper end-to-end services, primarily for 5G, cloud computing, IoT, and obviously the blockchain. And this is going to happen by the end of this decade, because the US government, for instance, they have already plans to move to IPv6 only for their networks by end of 2025 for their own networks, for the government networks. And on top of that, some of the interesting things coming out of this consultancy company called Roland Berger, and they say that $10 trillion of value of IPv6 will be impacted in this case by IPv6. And if you look at the numbers, manufacturing, government, transportation, and so on and so forth are going to be key fields, key use cases where IPv6 combined with blockchain are going to be very important.
Latif, I'm so sorry, Latif. I just for time here, I'm going to have to move to the other guys just so they can introduce themselves, and then we need to get into use cases in just a moment. But Lawrence, I would love for you to talk just super quickly about your peer-to-peer research and expertise here, and just if you give us a 2-minute quick intro, that would be great.
Okay. Basically, IPv6 is the replacement for the 1983 technology IPv4. It restores the end-to-end model that we lost when we deployed NAT and private addresses. What I work with is end-to-end direct messaging over IPv6, which is now possible because every node has a public address. And so, for instance, my phone could make a connection directly to your phone. And then I've gone beyond that and made a variant of TLS called peer TLS, where both of us have a client certificate, which gives us true end-to-end encryption and true mutual strong authentication. So we know for certain who the other party is, and it's encrypted all the way from me to you. No intermediary server. That's possible for the first time with IPv6.
Amazing. Can't wait to hear about how this actually improves things in the real world so people can get an idea of how big this really is. Mathieu, please, can you talk to us about Bitcoin certified addresses and some of that amazing research you're doing over there at Enchain? Nice and quick.
Sure. Thank you, Becky. So hi, everyone. I'm Mathieu. I'm a senior researcher at nChain. And so my background is in cybersecurity. And in my current role at nChain, I have various responsibilities. And one of them is looking at how blockchain networks can be enhanced with IPv6 and IPv6 related technologies. And conversely, how we can enhance IPv6 networks using the blockchain. So I believe it's a mutually beneficial relationship we have here. And in one of my recent work, which is entitled Bitcoin Certified Addresses, I'm showing how we can actually reuse the proof of work that is computed by Bitcoin miners to enable hosts to generate highly secure IPv6 addresses tied to their public key. So let me quickly go through how BCA works. If we want to explain BCA, we must first talk about CGA for cryptographically generated addresses, which is the technique from which BCA is derived. So CGA is one of these techniques made possible by IPv6 and its larger address space. And what it does is giving a way for hosts to generate their own IPv6 addresses. And this IPv6 address is derived from the host public key. And this is good for two reasons. One is that it is the management of IPv6 addresses. So it's very beneficial in situations where you have many hosts that are constantly joining and leaving the network, such as in mobile network or IoT network. And secondly, by linking the public key to the IPv6 address, you can prove ownership of your IPv6 address using digital signature. And this can be used to prevent many attacks related to address spoofing and enhance the security of IPv6 networks. Now, with CGA, there is a catch, which means if you want to generate your address, you have to solve a small proof of work, which is the exact same type of work that is being done in Bitcoin. Now, the difficulty of the proof of work, which will be, of course, much, much, much lower than what you have in Bitcoin, especially if you have an IoT device. But the effect is that the link, the binding between the public key and the address is not very strong, and it's relatively easy for an attacker to spoof your address. And so in practice, CGA are used as a temporary address on a local network. And then later, you will need to acquire a more longer-term address from your router. Now, what I have proposed with my recent work on BCA is to reuse the proof of work computed by Bitcoin miners to enable hosts to generate highly secure IPv6 addresses. Because the proof of work that is solved by miner is extremely high, so you have very strong binding between the public key and the address. So with CGA, if you want to spoof an address, you'll have to fight against users, which if you have enough resources is doable. With BCA, you would have to fight against Bitcoin nodes, except if you have millions in your pockets, there is no way you'll be able to defeat them and spoof an address. So this is one benefit. And the other one is that, as you can imagine, hosts in BCA, they don't need to solve any proof of work at all. So address generation is extremely efficient, only a microseconds, where it will take more than half an hour with CGA. So it's a win-win situation, right? And in practice, with BCA, you can use this address as much longer-term addresses to communicate over the wider internet, not just local network, as it is with CGA, but over the wider internet.
Very good. Very, very good. So I feel like I've kind of misled our audience. This has been a bit technical so far. We're going to break all of this down for you. So now you have the foundation here. And when I first started learning about IPv6, this is thanks to you, Latif, and the IEEE events, the easiest way for me to think about it, I mean, there's just so many more IP addresses available with IPv6, infinitely more than with IPv4. There's quite a few limitations with IPv4, which is what I guess I shouldn't say the majority, but there's still quite a few networks using IPv4. So I wanted to hear from you guys here. What is wrong with the current state of the internet, and in particular IPv4? So we can let our audience understand here why it's so necessary to make the transition to everything IPv6. So Lawrence, let me start with you on this one.
All right. Basically, IPv4 has been around since 1983, and it was very successful. In fact, it was kind of too successful. At the time it was released, nobody dreamed there would be 20 billion nodes connected to it. And unfortunately, IPv4 with 32-bit addresses only supports about 3.5 billion unique allocatable addresses. And so we had to kind of change to a scheme similar to like business telephones, where you have a one real number for the company and then maybe hundreds or thousands of internal extensions. That's what the private addresses in IPv4 are. They're really private extensions. And so you cannot accept a connection on that. So the internet has kind of divided into two layers. First-class netizens who can accept a connection and run servers, and second-class netizens who can only make outgoing connections with private addresses. Unfortunately, today, the majority of people only have private addresses. And so they cannot run servers and they cannot connect directly to other ones. So basically, many years ago, about 1995, the IETF came out with a successor protocol with larger addresses. And that's going from 32 to 128-bit addresses. That's not 4 times as many addresses, it's 2 to the 96 times. And so basically, with IPv6 now, every node in the world can have a unique, globally unique IPv6 address. And so now anybody, even your phone, can run a server, or I can connect directly from any node to any other node without any intermediary server. IPv4 forced centralization on us. So basically, you could make an outgoing connection to an email server, an FTP server, a VoIP server, or whatever, but you could not connect directly between two people that both had private addresses. And so there's kind of a way to fake that with Skype and so on using NAT traversal, but with IPv6, there's no need to fake it. You can do real peer-to-peer. And so basically, IPv4 has outlived its shelf life. And we ran out of public addresses in 2011. The regional internet registries ran out in the next few years, and now even the ISPs are running out. There's no more public addresses, and they're not making any more. They can't. And so IPv6 is the solution for this. And now something like half of the traffic in the world is over IPv6. Many of the telcos have already gone to IPv6 only. And so basically, kind of, we're going through a phase now where people are introducing IPv6 and doing dual stack, both IPv4 and IPv6, with the IPv4 kind of broken. And now the next step is to get rid of the IPv4 altogether, to go to IPv6 only.
Yeah, and Latif, I know this is an area you're super passionate about. You say there's even, people are still being even educated on these outdated protocols, which is just crazy. So can you talk to us a bit about the business reasons to make a transition from IPv4 to IPv6, and especially with enterprises in mind, because I know that this is who we're really waiting for. They're the ones that are a bit behind. So why should they be doing this? How are they going to benefit?
Well, one of the business cases is kind of mundane, but basically you can make connections faster over IPv6 than over IPv4 because you're not going through a NAT gateway. And it can make a difference of quite a few milliseconds in a web connection. And that sounds minor, but to people in the web industry, that could make the difference in keeping people's interest or not. And so basically, some people are willing to invest the money and make the change just to make those connections a little bit faster. But basically, it also simplifies the heck out of doing end-to-end connections and peer chats and things like that. And especially with respect to blockchain, there's a lot of things you really need peer-to-peer connections, not going through some central intermediary, but you need to have a direct connection from one to the other. That's really only possible with IPv6 today. And so that's a very strong use case. But basically, a lot of people now are realizing they need to actually have a presence on not only the IPv4 internet, but the IPv6 internet. And yes, there are two internets today. IPv6 is not backward compatible. So, if you're on IPv4, that doesn't mean IPv6 users can get at you and vice versa. And so you need to have presence on both internets today, and certainly on IPv6, because that's the only one that's going to be there in a few years. So that's a strong use case.
Wonderful. And Latif, what do you have to add to that?
Yeah, so thank you, Lawrence, for answering the question addressed to me. So,
we're all friends here. It's cool. We share.
Just compliment on your. So basically, due to the scarcity of the IPv4 address space, it has created certain monopolies. That's why we have top companies, the top 10, 20. They rule the internet. So instead of having a flat internet as it was designed, so where all peers are equal, now it's all centralized into a few hands. Quite interesting. Some companies are doing very good things, like Amazon. So they have announced 1st of February that they will charge anyone that is still using IPv4 few cents, but to them it will bring them $1 billion a year just by charging a few cents. So you can see that when you are in a monopoly situation, you can play with these things the way you want. So our voluntary effort for the last 20 years is to flatten the internet again and give each person his own IPv6 address, if not multiple IPv6 addresses, because now we can give every person a couple of million IPv6 addresses. At the beginning, they might use 5, 6, and so on, but down the road, with all of these IoT devices and so on and so forth, you would need many IPv6 addresses, at least to deflect from attackers. So you're not going to use the same IPv6 address. You can move from one to the other. Same thing will apply to enterprise. So we're going into a huge innovation that the internet today has been limited, if not monopolized, only a few hands. So I think we have a very noble task, all of us, to do that. And I can only congratulate Lawrence and Mathieu, especially by creating one thing that we don't have is the internet is not really secure. And it's very expensive to do security. So only the rich can do security. So the poor, we are all hackable. But the hackers, they don't care about small guys. They will go for the banks and so on and so forth. But I think down the road, if they are stopped by all of these banks, they will go after each person, not to take away something from them, which is happening today. So we're not doing much, to protect citizens and users, especially the new generation. It's really affected now by all of these ransomware and so on and so forth. So I think blockchain can be a very good answer down the road, to at least have worldwide flat blockchain, single blockchain that can be used for all kinds of scenarios. Okay.
Very good. Yeah. So I think somewhere in there, Latif, you were saying that there's cost reduction. If we move to IPv6, it's more secure. You don't have to spend all of this money on security issues and things like this. So cost reduction is one big major reason why enterprises should be looking at this very, very seriously, I would think, and for sure new lines of business. Mathieu, in particular, I know that you're super focused on Bitcoin certified addresses, but when it comes to examples of new business use cases that I'm going to call it BCA, or maybe actually probably easier if I call it just Bitcoin certified addresses, IPv6 blockchain altogether, what can this provide for enterprises?
Yeah, so I think I'd like to come back here to the peer TLS protocol that Lawrence developed, which I think the BCA, the philosophy behind the two is very much aligned in that they can both enable two clients to communicate directly with one another over the public internet. So with BCA, what we do is putting the public key on chain. But actually from that, we can do much more. So for instance, we can add certificates that would be stored on chain and that would link the public key to a domain name. So thereby identifying the public key. And then we can use the blockchain as the single source of truth from which we can get information about, for instance, the status of the certificate. So if it's active, revoked, if it has been updated. We can also generate multiple transactions linked together and have addresses that are provably linked together. So I believe with BCA, we can automate lots of process that exist on the internet for setting up secure communication. So this can be domain name resolution, this can be certificate management, but in all case, we're using the blockchain as our single source of truth at the data layer from which we can get trustful information about clients. And so one use case I would be very enthusiastic to see would be having wallet providers that leverage BCA to enable two users to exchange Bitcoin payments directly with one another. And this would be an improvement in terms of security, in terms of privacy, but also in terms of scalability over existing payment solutions where all the transactions have to be relayed through third party.
Very good. Thank you. Oh, yeah, go ahead, Latif.
A good example, Becky, on where you can use a blockchain. So this is Mongolia. And in Mongolia, they have a tradition when they sell a piece of land or a house or something like that, they basically shake hands. You know where the shaking of hands comes from? 1,000 years ago, when people want to make peace, they showed their hands without a knife on it or something. This is where the shake hand comes from. And what happens is, recently they have seen that a lot of crooks, they go and sell a piece of land of somebody else with a shake hand. Then all of a sudden the government has seen that a lot of this beautiful tradition has been now hacked. So they appointed, after certain research, they appointed a Canadian company that installed at their place a blockchain for smart contracts. And then they key in all the ownership, the land and so on for each one. So whenever something has to be sold or bought or something like that, they have to check on the blockchain and see to whom this place belongs to and so on. So not that everyone can go and sell somebody else. And then when somebody comes to the house, the people are living in it and they tell them, well, we have bought this house. I tell them, well, I can sell it myself. And they get into a fight. So it's quite interesting that very old place like Mongolia has come up to use new technologies and leapfrog, to resolve a massive problem in their country. So there are many scenarios like this. Okay?
Very good. Thank you so much, Latif. And Lawrence, anything you wanted to add about business use cases?
Yes. One of the big use cases of IPv6 is being able to decentralize things. Centralization is where most of the hacking and snooping happens. And so, IPv4 has forced centralization on us. If we can decentralize everything so that I can talk directly to you without going through any intermediary node, that will eliminate the majority of hacking and snooping and things like that. So that's a big win there. There are other things like multicast streaming works really well. So in the future, there's not going to be 300 cable channels. There's going to be 300,000 video and audio channels from all over the world over IPv6. And so, again, this makes an enormous change in the way we do things like that.
Amazing. I love that you brought up multicast because I'm going to be asking about that after the break. Very excited to dive into that one. And before we take our break, I just wanted to hit one more topic. We do have one question. Hopefully some more will come through. I did say that the subject of this was future internet, and we can't mention future internet without including Web3 and IoT and AI and all of these amazing terms that everyone can't stop talking about. So I was just hoping that you guys could maybe provide some examples of how IPv6 is going to actually enable these, I hate to use the term buzzwords, but that's kind of what they are, to actually make an impact on the world like everyone believes they're going to do. Where does IPv6 fit into these terms? So I will start with Latif. Latif.
Yeah, that's a billion-dollar question.
It's a big question.
First of all, we have to standardize blockchain. It's not yet standardized. We have to standardize so Web3. There's a bit of confusion regarding Web3. So we have Web1 designed by Tim Berners-Lee, Then Tim O'Reilly has started Web 2.0, which was not based on standards, but based on basically Facebook and YouTube and so on, as animated internet, which was not the case for the HTML at that time. It was just fixed text. And that upset Tim Berners-Lee. That's why he designed Web 3.0, which is semantic internet. But somehow it didn't pick up as it should be. And then all of a sudden we have gentlemen that started the Web 3, who probably didn't know that Web 3.0 exists. So the purpose there is to use it for blockchain. So in order to implement it as such, we're not talking about just an application layer, we're talking about also networking layer. Because you have nodes that do blockchain, so it's partly networking and partly applications. And this is not yet standardized. So there's a lot of marketing that's normal for any new technology. You have more hype than real stuff done. So we need to standardize these two pieces so that we have kind of worldwide implementation of Web 3. If Tim Berners-Lee also plays, because for the time being, he doesn't want to hear about that one, because he says the web is decentralized anyway. So why are you bringing something new? So, but then blockchain is not part of the work of the W3C. So it should be standardized, and where? It will be the ITF. Now the ITF is not looking at it because they are scared of the crypto side, which has kind of dirtied the name of blockchain. So we have to clean blockchain away from the crypto thing. So there's a bit of a couple of years of work to clean the brand of blockchain, which has nothing to do with crypto. Crypto is only one scenario, but the bigger scenarios are still there. Okay?
Yeah, very good. Thank you. And Matthew, what are your thoughts on this? I mean, I know it's a huge question and it would take hours to really get into so much detail here, but all of these things I've talked about have so much to do with data. I know that. Give us your thoughts on how IPv6 and blockchain fit into these buzzwords.
So yeah, I'm very enthusiastic about the IoT landscape, and I think blockchain has a crucial role to play here, and IPv6 as well. IPv6 for the fact that it enables these two devices to exchange information in a direct and secure way, and blockchain because it enables, on top of that, the exchange of value. And by combining the two, you can have this direct exchange of value, which I think will become fundamental in the way people will interact with all these connected devices that we'll see spread out in the future world.
Yeah, to complement on this one, as a matter of fact, IoT is going to be tremendous because we're going to talk about peer-to-peer IoT. So it's things through things. They talk to each other. It's stupid that we talk to them. They should talk to each other and give us just essential decision-making information. So most of the IoT things today are, point to point. They don't have to talk to each other. To look at whatever scenario you have in agriculture and so on and so forth. If the water is not needed in this place, then concentrate in this area. So there are many projects that are now running across Europe where they're using IoT for, to look at temperature and so on and so forth, because water is fundamental. And you need to have devices in order to do that. So the devices have to talk to each other and then tell you what you can do. If you have 200 hectares of vineyards, you're not going to run across these things because you lose half a day just going from A to B. So there's a lot of potential in making agriculture more effective and more producing, and cut the loss of the food that we have. You cannot imagine that basically we lose 50% of the food that we buy. Nobody knows how much is lost on the table, because at the end we don't eat everything. Okay? Now, the governments themselves, they have really strict rules for all kind of thing. In the case of Luxembourg, I was talking to the lady who's responsible for meat, and she says we have very strict rules, but we don't have the tools in order to verify if the meat sold in the shop is pure Luxembourg, or is it mixed from meat that comes from Romania and some other places because they are low cost, but they sell them for the higher price of these things. So she would like to have a QR code to go to any shops and look at it. And if she has some doubt, she can go inside and ask the guy what's there. But they don't have the tools today to do that. So you can imagine the work behind it. You have to have a database, call it blockchain, in order to know exactly where these things have been produced and the channel, the distribution, and so on and so forth, so that at the end, your QR code has a certain decision-making data. So in front of us, we have at least 10 to 20 years to automate all these things. The benefits will be that the producer will talk directly to the end user. The producer will get more money, and the consumer will pay less. Because in between, you have a Ponzi scheme. They know how to buy, and they mark it up, not to sell it to you for a high price. They're not doing anything, just from an office. And he doesn't care about the quality of food and so on and so forth. So in every sector, we have a Ponzi scheme in between. Car dealers, whatever dealers in between. Because they know how to sell things and how to buy it at lowest price. Because nobody can prove what's the margin these guys are making.
Yeah.
So there's potential of reducing the paying for the rights of producer and lowering the price for the end user.
That's a great use case. And Lawrence, I'm certain that you have some examples of how peer TLS can superpower IoT world and some of these other areas. What thoughts do you have to add?
Well, in terms of IoT, today we're really restricted to IoT and only working within a small subset of the internet, the local area network, because of the limitations of IPv4. With IPv6, essentially there's no limit. The IPv6 internet is global, and any node in the world can connect directly to any other node. So you could create IoT deployments that literally are distributed all over the world, not just within a small network. And so that's an enormous jump forward. But one of the big things is in messaging. Right now, all the existing systems out there, Skype and Slack and Messenger and all those, basically have to work within the context of IPv4 with NAT. And so they all use NAT traversal, and it's all centralized, whether you notice it or not. There's an intermediary node, and so everything is centralized. And so again, with IPv6, for the first time since the early IPv4 internet, literally any node can connect directly to any other. And that is a fundamental, enormous change. As an example, with multicast, I happened to be living in Atlanta when Ted Turner realized that a communication satellite was an incredibly tall TV antenna that could reach a third of the world. And he put a transponder up there, and his little bitty 5,000 subscriber UHF station became a 5 million subscriber, network overnight. And that led to CNN and a dozen other networks. That kind of jump in scale is going to happen with IPv6 streaming over multicast. Literally anyone in the world with a notebook computer could set up a network that could have 10 million people watching them, because multicast gets replicated in the network. So you don't need an enormous amount of horsepower at the original site. And this is going to fundamentally change things. There's one thing that's going to happen is somebody's going to have to create something like Google, but for finding IPv6 streaming casts and so on. There might be 30,000 Hollywood or Bollywood music video channels out there. And so there's going to have to be something like Google for finding things in that enormous wealth of new channels and so on. So many, many new things are going to happen because of this jump in scale.
So exciting. And I know there's implications for Bitcoin mining as well, which we'll get into in a second. But first, I wanted to take a quick question break. We have one question right now. And this is from Nelson Vietti. How can we ensure the future internet remains accessible to everyone, including those in remote areas? So who would like to provide an answer to this one? I think I see Lawrence's hand down there. Okay.
I happen to have spent a lot of time in the Philippines, much of which is very remote. And basically, it's been very difficult because it's an island nation with like 7,000 islands to provide internet to everyone. And the breakthrough has come from satellite internet. So our good friend Elon Musk has put up an enormous constellation of satellites, and that basically makes the internet available to literally anyone. And so I've got a friend over in the Philippines who is going around setting up kind of relay stations in the mountains and places like that to bring internet to people that never would have gotten it before. And so again, because now there's a lot more people that have access, we have an even bigger need for having unique addresses. And so that's pushing the need for IPv6 even further. We can't really handle, 8 billion people with IPv4 addresses, I'm sorry. And so to reach that level of scale, to make it available to everyone, we have to have IPv6.
Amazing question. Great answer. Go ahead, Latif, please.
Quick response. So this is basically connecting the unconnected, and a lot of people doing conferences and government talking about the digital transformation. They have nothing behind those fancy words. Instead of just looking at the internet infrastructure and giving some regulations. And I have a very nice case in France. So the regulator itself, called ARCEP, they have put IPv6 as mandatory for the mobile operators. If they want to deploy 5G, they have to commit to IPv6. And that's why France now is number one in deploying IPv6 with 75% V6 penetration. So you have only pockets where knowledge is there, and the regulator has the capacity, to understand where to get these guys and get them to do that. So we're promoting this concept now across Africa, to get the governments, because they are the first customer, so they have the purchase power. So when they want to do something, they'll be the first one to ask. But unfortunately, the level of capacity building is not very high in those places. And then they get lobbied by these mobile operators over dinner or lunches and so on and so forth to give them time, to do that, because they want to milk the current internet as much as possible. And they don't really care about the country as such. So I think taking the example of France is very important. This is what we are doing currently in Africa, to get everyone, as you know, Africa will be about 1.5 billion people in 20 years. So it will be the biggest kindergarten continent in the world. And without education, there will be a lot of suffering. So education is fundamental, and the cheapest way of doing that is getting them access at least to some generic knowledge through the internet. So the question is very important. So we have to get all the governments, United Nations and so on, to work on these things, because they talk to the governments. And this is not really happening as such. So unfortunately, we are spending too much time on wars instead of that money spent. Even in Europe, we have 25% do not have internet access. I would imagine 10, 15% in the US. So the other countries are still behind. Although Google says there are 5.5 billion people using the internet, but then what happens with the rest? They will never have a chance. So everyone should get a chance.
Yep. Amazing points, guys. Thank you. And we do have one more question to take. Thank you, Alex. Hello. What positive or negative societal changes might the blend of these different techs bring? Who would like to tackle this one? Anyone? Lawrence, please.
One of the differences is with IPv4, there was a very inequitable distribution of public addresses. The US, with 5% of the world's population, got about 40% of the public IP addresses. It's partly because we invented it and then we shared it with the rest of the world, but still, China was not at all happy with the fact that they could not really take advantage of the internet because of lack of IPv4 public addresses. And so with IPv6, this is the first time it's a truly global internet. And any country can have as many public addresses as they could ever conceivably imagine a need for. So there's no inequitability anymore. It's a truly global internet. And so this is going to allow every country not just the leading countries, but every country to really leverage the internet for the first time. And this is going to make a big difference. This is going to kind of democratize the internet, you might say, just because of the existence of the necessary public addresses. So this is a very big change that we're doing.
That's great. And Lawrence, hearing you talk is reminding me of some of the amazing sessions I've heard about the Bitcoin network and how this opens up the global commerce and the economy around the world. And you can see why these things fit together. And Mathieu, I've been dying to talk to you about Bitcoin mining here and about the multicasting of IPv6 abilities and how this is going to really, I guess I could say, improve the way that the Bitcoin network functions. Can you just give us a quick summary of that?
Yeah, absolutely. So the Bitcoin network, I mean, it's all about fast dissemination of information. So as user, I want to submit a transaction. I want to make sure that this transaction will reach as many nodes as possible. As a node, if I find a block, I want to make sure that when I find it, as many nodes as possible are notified that I found it. Same thing for Merkle proofs. So how it's being done right now is mostly using unicast, IPv4 and multicast, which is not very efficient because it means that I have to send one packet to each node that I'm connected to. Now, instead, if we can use multicast with just one packet sent, we can reach the same number of nodes. So it's much more efficient, and it would improve a lot the efficiency of the Bitcoin network. And the advantage of using IPv6 for multicast is that it simplifies a lot the allocation and the management of the addresses. And compared to IPv4, you have no risk of collision because of the larger address space. So I think this can be really game-changing in making Bitcoin networks more scalable.
Yeah, it's so exciting. And Latif, I know I've heard you talk quite a bit about the wonderful fit that IPv6 and in particular BSV blockchain have together and how they were built, with each other in mind. And could you just elaborate a bit on why this is the case?
Yeah, so basically it goes back to what Lawrence was talking about, peer-to-peer. So peer-to-peer means that everyone is at the same level. And what Mathieu has demonstrated is that even if you have peer-to-peer, you don't know which source IP address and which destination address is. So you have to verify them, okay, so that you know exactly that this is the one and the other one is exactly the destination. So that's why he introduces, in this case, a certification of the address in order to make these links to be pure, so that these are the real ones. So spoofing will not be allowed. Because especially we're talking about money transactions, even if it is small payments, you want to have something which is real and true, and then the connections are going to be accepted on both sides. So this is where this basic function is the essence of any scenario. Adding micropayments to it, which is fundamental. So if we take Africa, so for instance in Kenya, they have what is called M-Pesa, mobile pesa is money, mobile money, and it's a French company, which is a France Telecom, Orange, and they have introduced that system in Kenya, and they use only the mobile phone. So all of the farmers and so on, they sell their products through the phone. They don't have to go to a bank or see money. Everything is on their cell phone, not iPhone. Cell phone, normal one. And this is the biggest application in the country. So the entire country is done this way. Unfortunately, they wanted to do it in the other countries. The mentality is not there. So it did not succeed in those places. But they introduced it in India, and it's working, but not as fast. So this kind of applications are fundamental to developing nations because they don't have banks. They don't know how to write. So you have to make it very simple for them. And very reliable, and so on and so forth, so that they trust the system. So introducing trust in the internet is really critical. And this is what's missing today. And all what we hear hacking here, spoofing there, and so on and so forth. Cybersecurity is a big issue. So we have to do everything possible to stop all these malicious things that are happening, for the smallest hacking to the biggest hacking that exists. And I'll tell you, a lot of people are working on these things, but the hackers are, a couple of steps ahead. So we need to invest in security, in cybersecurity, and using very easy applications like, BCA, and then deploy it and see how it functions, how it scales in certain applications. And this is most probably one of the biggest challenges we have, to get these things running on site and to demonstrate the case. So big pilots are going to be fundamental. So we'll have to work on getting big guys to do this work. Okay?
Very good, Latif. Thank you. And Lawrence, anything to add on the fusion of IPv6 and blockchain?
Okay, basically, the two fit together beautifully because blockchain really was designed for peer-to-peer type applications. And IPv4 forced centralization going through intermediary nodes, which introduces security issues and just scalability issues and things like that. And so for the first time, blockchain can actually be implemented not only peer-to-peer, so that any blockchain node can talk directly to any other blockchain node in the world, but they can do it securely with pure TLS. Pure TLS is an enormous jump forward over conventional TLS. TLS was originally designed for web browsers connecting to web servers, and it does a great job there. It allows the web server to authenticate to the client, so you know for certain what web server you're talking to. Pure TLS takes it one step further, and now when I make a connection, for instance, with VoIP, I can know for certain who I'm talking to, and they know for certain who I am, and it's encrypted all the way from me to you. There's no centralization, no intermediary node. So this makes a giant leap forward in privacy, in knowing for certain who you're talking to and things like that. That isn't possible with the IPv4 internet. But in blockchain, this end-to-end is critical, and not only end-to-end, but secure end-to-end. And so we need not only IPv6 for the end-to-end secure connectivity, but we need the pure TLS to actually make it completely secure. And one interesting thing, the TLS certificates, the server certificates identify a node, so you know what node you're connecting to. Client certs with pure TLS identify the person. So I don't care what node you're working on. I'm interested in who you are. And so with pure TLS, both people know for certain who the other end is. They don't care what node you're using, what phone you're on or whatever. They want to know who you are. And so again, that's an enormous shift in focus going from conventional TLS to pure TLS.
So to compliment on Lawrence, to simplify it and the impact on us. So by having NAT in between, it kills basically the security on the email. So normally email has to be secure so that you can encrypt everything, and when it comes to you, it encrypt it. But now email is in the clear, which means anyone can read our emails. We take it for granted that our email come to us in the clear. That is not normal. Even the post office, you send a letter in an envelope, and nobody dares to open the envelope. That's the kind of little trust we have there. We don't even have that on the internet. All emails are in the clear. Guess who is reading it? Everyone can read it.
Right. Well, with email, I've been working with email for a long time. In '98, I released a book on internet email that discussed how to secure it with something called S-MIME. And so you can secure email with S-MIME on IPv4, but that requires setting up an elaborate PKI and individual client certificates, excuse me, for everyone, which is fairly difficult. With pure TLS now, basically, it's a lot easier. It's kind of the people using it don't really have to know that it's happening. Just when they connect, they'll be able to know for certain who they're talking to, and it's encrypted end to end. So you don't have to go to the trouble to set up the S-MIME infrastructure and issue everybody an S-MIME certificate and so on. It's kind of as simple as connecting to a secure web server, but now applied to end-to-end messaging. with various protocols, not only email, but also chat, VoIP, and so on. So that can be used to secure all of those things end-to-end direct.
So that's what SAP is doing, but using the phone numbers as identifiers.
Yes, basically with phones, traditionally we use numeric phone numbers, like 123-4567 or something. And we kept running into problems that we didn't have enough numbers, and so on kept going to longer and longer phone numbers. Well, basically with IPv6 now, all global telephony is collapsing into just one subsystem of the IPv6 internet. And your phone number is going to be something like sip:/LHughes@hughesnet.org. And there's no limit to that. You can have an infinite number of those kinds of phone numbers. And so, and it scales better too. So basically, all telephony is, taking a giant leap forward. And in fact, 5G is kind of the grand convergence of telephony and internet. And so IPv6 is making that possible.
Oh, this is so brilliant. And in the couple of minutes that we have left, I just wanted to leave a nice message here for enterprises out there and businesses that are aware of what you guys are talking about, but maybe they haven't actually done anything about it. I'll tell you, as someone that grew up with a father who worked for Polaroid for many, many years, I saw what happened when digital photography came along. It was like this, and they went straight downhill because they just missed the boat. They did. Polaroid and Kodak. We don't want this to happen for our viewers out there. What kind of a message would you guys leave for our friends who are kind of on the fence? They want to get involved. They're not really sure what to do. We have literally a minute per person. Just your final message before we have to finish the roundtable. So I'm going to start with Matthew.
Yeah, sure. So I think, as researchers, so it's our role to develop these new technologies, but we also have to make sure that we can communicate how these technologies can be implemented and how they can bring new use cases. And so that's something we're doing at nChain. So we have a big group of researchers, but we've also have integrated engineers that are developing prototypes for our inventions. So I'm sure in the coming months, you'll see more coming up with our research.
Brilliant. And Lawrence.
Okay, all of the companies that are doing messaging now, like Skype and Slack and things like that, they need to start figuring out how to take advantage of end-to-end direct now, because if they don't, they're going to be out of business in a few years, because the ones that do manage to make that leap and start providing end-to-end connectivity are going to win all the business. And today, things like Teams will only work over IPv4. Same thing with Skype and so on, because they're based on IPv4 NAT traversal. And that's very difficult to migrate to IPv6. So basically, anybody doing that kind of work has got to master IPv6 and start understanding decentralization today.
Brilliant. And Latif.
Yeah, I would recommend to anyone listening to us to have a plan to become a guru in IPv6 and blockchain, and your life will change. Thank you.
Yeah, Latif, you're absolutely right. And also, I would really like to encourage anyone watching here that if you want to talk more about this, learn more about this, hear more about this, I know that the London Blockchain Conference, which is, I believe, the 22nd to 23rd of May, is going to be really diving into all of these topics. And it's such an exciting area. And so please join us there. Thank you so much. Latif, Lawrence, and Matthew, you guys have been absolutely amazing. And thank you so much to our viewers for joining us today and for your questions. And please don't forget to subscribe to the CoinGeek channel so you don't miss the next roundtable. And we'll catch you next time. Thank you.
I would learn how.
Bitcoin mining, Bitcoin wallet, blockchain, stablecoins, MetaNet, the evolution of money. Everybody is talking about Bitcoin today. But what exactly is it? Learn the basics from experts. Learn what Bitcoin is, how it works, and why it matters. Blockchain 101, your ultimate guide to the fundamentals of blockchain.